Hello students, welcome back to the course on operations management, and this is the second lecture, and today we are going to talk about productivity. We have seen in the first lecture that operations management is about transforming certain inputs into certain outputs through a set of processes and managing them. I just depict it with a very simple picture here. You see that these are all the inputs that we have, and when we talk about inputs, we are not just meaning the raw material input, but also the labor, capital, energy, and the raw material input. And the outputs can be, as we have seen, it can be either goods or services. And the whole term called the productivity is actually a measure of performance for the operations management. How efficiently we can convert the inputs into a set of outputs is what is measured through productivity, and that is a key fundamental metric of performance for operations management. Let us look at this with a very simple example. Okay, here I have given three cases, three scenarios, and we need to find which is the most effective process. In the first case, 100 units are produced by 1 manpower. Here, which is the input and which is the output? 100 units is the output and a man is the input. So we know that productivity is nothing but output by input. The output here is 100 units and the input is 1 manpower, which is equal to 100. In the second case, 200 units are produced by 2 men, which again means 200 units divided by 2 manpower, that again equals 100. In the third case, 400 units are produced by 3 men, which means 400 divided by 3, which is equal to 133. Now you can find which is the most effective or most productive process 3. If you do not express the efficiency in terms of productivity, you can get confused by looking at these three statements, that here it is 400, so this is the most productive one, this is the next productive one, and this is the least productive one, is what we will conclude. But actually this is the most productive one and these two are equally productive. So when we express productivity, we are expressing it as a ratio between the output to the input. How much amount of input is utilized in order to produce a given output, or how much of output is produced with a given set of inputs. This essentially means the operations management efficiency. Let us move on to the next point. We can express the productivity in two terms. Why do we need to express the productivity in two terms? We have seen that there are certain set of inputs in our previous slide: labor, capital, material, energy. And when we say it is a ratio between the output and input, which input we should take into consideration for measuring the productivity? Should we take the labor input? Should we take the capital input, or material input, or energy input, or all of them together? Which input should we take for expressing the productivity? To handle this problem, we have two different measures or two different ways of measuring the productivity. The first one is known as single factor productivity. As the name implies, we just take any one of the input for expressing the productivity. And it is mostly the labor hours used or the manpower used which is taken as an input for expressing the single factor productivity, while you can take the other inputs as well, but conventionally it is the labor productivity which is expressed in single factor productivity. In our previous example wherein we have calculated the productivity like the 100 units produced by a man, 200 units produced by two men, etc., are all single factor productivity. What is the next productivity? It is known as multi-factor productivity, or it is also known as total factor productivity. A multi-factor productivity takes into consideration more than one input. It can be labor plus material, labor plus energy, or any combination, but it takes more than one input. It can take all the inputs as well. So the productivity formula for multi-factor productivity will be output divided by the sum of all the inputs or more than one input, as the case may be. Let us look at a simple example here. Compute the multi-factor productivity for an organization that produces 100 units. When we say produces 100 units, this is the output, we know. Right? And what are all the inputs? 10 labor hours is one input. 250 kilogram of raw material is the second input. 100 units of electricity is the third input. And with an investment of $200 is the fourth input. We know that productivity or total factor productivity is equal to output divided by sum of all the inputs. So what we do, the output here is 100 and divided by the sum of all the input. Can we do that? 100 divided by 10 labor hours plus 250 kilogram of raw material and 100 units of electricity and finally $200 of investment. All put together it is 0.18. 0.18 what? This is erroneous. You know that this is erroneous. While we take this formula, one important thing that you need to do while calculating the multi-factor productivity is that all the inputs should be expressed in 1 unit of measurement, and conventionally all the inputs conventionally will be expressed in terms of the currency, which is the easiest one. So what you do is that convert this 10 hours of labor into a currency value based on what is the per hour labor rate for that country or for that organization. 250 kg of raw material converted into a local currency, 100 units of electricity again converted into a local currency, and this $200 is already existing as a local currency. All put together, if you calculate, then you will get the multi-factor productivity. Okay, so this is how you calculate the multi-factor productivity. Before we get on to the next slide, I would like to show you a simple video that talks about the productivity.
We operate 230 supermarkets and approximately 175 convenience stores, supported by 7 retail support centers. There's basically 2 major challenges we have, and that is travel time and touches. So as we look at different opportunities around put away, high lift work, replenishment high lift work, selection, There's travel associated with those functions and touches associated with those functions. And anytime we can eliminate travel or touches, we as a company are saving money. Incorporating the Raymond automated lift truck into our warehouse environment has allowed us to do that, specific to the put away function, by reducing the amount of touches and the amount of man travel that occurred in days of old. The Raymond automated lift truck has got us the benefit of moving a pallet from point A to point B. So for example, that point A to point B may have been a 4-minute task in the past. Now that task is 2 minutes. So we improved the productivity on those specific Raymond automated lift truck hauls by 40 to 50%. What differentiates Raymond automated lift trucks from others is flexibility. I don't have to cut holes in concrete. I don't have to lay wire. I don't have to have reflectors on the rack. I don't have to have all those things that other automated providers may require you to do. With the Raymond automated lift truck, all I have to do is retrain that lift truck on a new route. Our team members have the ability to service our retail stores at a different level than in the past by utilizing the Raymond automated lift truck, along with making our shopping experience for our customers much better in the future.
That's an interesting video, isn't it? This company, they have trained the robotic vehicle to handle material without the manpower. So they are actually increasing or improving the labor productivity by investing certain amount of money in the robotic vehicle. Let us look at this. If you are the operations manager, the one who has actually explained to you, if you work for an organization, something similar to that, but in India, and if you have to invest, say instead of $20,000, I mean to say, instead of $20,000, suppose you need to invest, say 20 lakhs in a similar robotic vehicle. If you invest 20 lakhs in a robotic vehicle, you will be able to eliminate one manpower. Suppose you can do that. Will you go with this proposal? Here, when you try to calculate the productivity, if you go with a single factor productivity, the benefits will be very immense because you are eliminating one manpower altogether. So your productivity will show substantial improvement in terms of labor. But if you take a multi-factor productivity, you will take the savings in manpower. At the same time, you will also include the fresh investments of 20 lakhs into the system. So you will use the multi-factor productivity to evaluate this case. If you do that, what are all the factors that you will take into consideration for assessing it? This is a tutorial for you. You can think about it. And the next question is, if the unit is a service industry, will your assessment be different or will it be the same? Will you simply take the labor cost and the investment, or will you take several other aspects into consideration? This is the next question for you. And if you work for a restaurant which has both production as well as service, will your decision be different? These are all the questions for you for your tutorial. Let us conclude this lecture session with a quick test. Here is the first question. Productivity increases when the input increases while output remains the same. Is it right? The input increases while the output remains the same. Option B, input decreases while output remains the same. Option C, output decreases while input remaining the same. Option D, input and output increase proportionately. And the last option E, input increases at the same rate as output. What do you think is the right answer? The right answer is input decreases while output remains the same, because this productivity is a ratio between output to the input, and when the input, that is the denominator, decreases, the productivity increases. So input decreases while output remaining the same is the answer for this first question. The next question is, productivity means option A, can use many factors as the numerator. Option B is the same thing as production. Option C, increases at about 0.5% an year. Option D is dependent upon labor management and capital. And the last option E is the same thing as effectiveness. Which is the answer you think is right? And the right answer is dependent upon labor management and capital. The next question. Single factor productivity remains constant, is never constant, is usually uses labor as a factor, seldom uses labor as a factor, and uses management as a factor. We have seen that single factor productivity conventionally uses labor as a factor. The last question, multi-factor productivity remains constant, is never constant, usually uses substitutes as common variables for the factors of production, seldom uses labor as a factor, and always uses management as a factor. And the right answer is C, which is usually uses substitutes as common variables for the factors of production, which means that the inputs are all converted into a single unit of measurement and used for computing the productivity. With this, I end the lecture 2. Thank you very much.